Hello, welcome back to the channel again. Let's solve another challenge. Today's challenge is from LeetCode 207 course schedule. So, problem definition is the following. So, there are total number of courses that you have to take, labeled from 0 to number of courses minus 1. And you are given an array prerequisites. If you want to take one course, there is always prerequisite that you have to take that course first. So, for example, the pair 0, 1 indicates that if you want to take the course 0, you have to take course 1 first. And our task is we need to return if we can finish all courses. Otherwise, we need to return false, that we cannot finish all the courses. And to get the degree, and we have to finish all the courses. So, example 1, number of courses there are 2, and prerequisite is 1 and 0. So, we have to take course 0 first in order to take the course 1. So, there is only one course 0, then we can take that 0 course, then we can take one course, so we need to return true. And next problem, next example, we can see to take the course 0, we have to take course 1, and we have to take the course 1, we have to take the course 0. So there is a cycle. Then we cannot take, because both courses, they have a dependency on each other. So we need to return 0, and we need to return false. So let's look at the constraints. So number of courses, the range is from 1 to 2,000. And the length of the prerequisite is 5,000. And the prerequisite, each element in the prerequisite is 2. So the courses can range from 0 to number of courses. All the pair prerequisite I, they are unique. So let's look at the example. Okay, we have here example 1, number of courses is 2, and the prerequisite is 1, 0. We can say if we want to take the course 1, we have to take the course 0 first. So we can say that the course 1 is a course and course 0 is prerequisite. So how we can take the order of classes, we can take first, we can take the course 0, then we can take course 1. So here we can return true. Let's look at the second example. Let's say, so in here, that the course 1 is the prerequisite, course 0 is the course. So to take the course, we have to take the prerequisite. And the next one is the course 0 is prerequisite, and the course 1 is a course that depends on the course 0. You can see to take the course 1, we have to take the course 0. And to take the course 0, we have to take the course 1. So there is a cycle. So there is a dependency, right? Each course, they belong to each other. So to take the course 0, we have to take the course 1. But to take the course 1, we have to take the course 0. Right? So here, so we need to return false. So each of these nodes, they represent one class, right? Let's look at the example. There are 5 courses. Basically, this courses, this list, it shows the number of courses and their prerequisite. To take the course 1, we have to do the course 0. It's good. So we can do the course 0 first, then course 1. After we take the course 1, course 2 depends on course 1. So we can do the course 2. Then after we are done the course 2, that there is a course 3 depends on course 2. Right? Then we can take this one for course 3, then we can take course 4. So the order is 0, 1, 2, 3, and 4. So there is no cycle. So there is no dependency on the courses on each other. So we can easily finish. So we need to return true. Right? In the core example number 4, you can see to take the course 1, we have to do the course 0. To take the course 2, we have to do the course 1. We have to do the course 2 to take the course 3 here, right? To take the course 1, we have to take the course 0. And course 2 depends on course 1. So it's good, there is only one. Then course to take the course 3, we have to take the course 2. But you can then to take the course 4, we have to take course 2, which is okay. So once we take the 1, 2, 3, 0, 1, 2, 3, and here at the same time we can do course 4. But there is a problem. To take the course 1, we have to take the course 3. But to take the course 3, we have to take the course 2. To take the course 2, we have to take the course 1. You can see we can take this way, right? Course 0, course 1, course 2. But the course 1, we cannot take it because to take the course 1, we have to do the course 3. So we can see that there is a cycle, right? So there is a cycle exists. If there is a cycle exists, we need to return false because we cannot finish the classes. So basically, this is this problem we can formulate as a graph problem, right? So all we need to do, we need to count number of courses that we start from beginning. We start counting. Okay, after we take the course 0. Okay, number of courses I finished is 1. Total number of classes, there are 5. At the end of all of the visiting each class, and we will see oh, what's the number of courses that we have left so far, right? Let's see how we can solve this. Okay, this is basically from 0, 1, 2, and 3, and 4. So we can see this is an example to a directed acyclic graph. Direct means from 0 to 1 there is a direction, and acyclic means that there is no cycle. So each course does not have each course has there is no cycle in the graph, right? So total number of courses, there are 5. So the first step, we need to, in the graph problem, the easiest way is we need to form adjacency list. So we can see adjacency list from 0 to 1. So there is a connection, right? And from 1 connects to 2, and 2 connects to 3, and 3 connects to 4. And 4 doesn't have any exit, right? Basically, it ends here. So what we're gonna do? So idea is we need to get the first course which has 0 dependency, right? What is the course which has 0 dependency? Here is 0, right? So the course 0 does not have any prerequisite. So we should start taking the course 0. Okay. After we are done with the course 0, then we take the course 1. So what we do, there is so we say that, okay, this is in degree. In degree means the number of edges incoming to that node, or to the class, right? Basically, this edge, it says that there is a prerequisite, right? So this course 0 does not have any prerequisite, right? So we can take the course 0. We can start from the course 0. After finishing this to get this course 0, we see this in degree means how many edges incoming to the node, right? So that is 0. So we start taking the course 0. We add that to the queue. Okay, just it's the list that we start taking, right? We put this to the queue. After we put this to the queue, then we take it, right? Because that's in degree is 0. So we add whatever the course has in degree is 0. So we add that to the list of the classes that we can take Now it does not have any prerequisite, right? After we are done taking, we pop this queue. Then, okay, we are done with this, right? Let's change the color. Okay, we are done with this. Okay, we took it. After we took it, so then this we can break it, right? Then we decrement this one to 0, right? So because this course 1 depends on course 0, now course 0 is done. So this we need to update this to 0, right? After that, we add this 1 to the queue because it has in degree of 0. Because in degree of 0 means it does not have any prerequisite. It had a prerequisite, but we already done with it, right? So course 0 is done. Now we add the course 1. So we take it. After we are done with the course 0, we increment the number of courses taken. So after we are done with the course 0, we increment this one to 1. Then we add this 1 to the queue. Okay, we add it. Then we pop it. Then we take that course because, right? After we are done with that, then we increment this one to 2 because 2 courses we are done. After we are done with the course 1, we finish. We break this this connection because 2, all the prerequisite for 2 is done. So right now we decrement this one from 1 to 0 in degree, and we add that to the queue to take that class, right? Then after we take this, then we pop this 2. Then after we pop the 2, then what we do here, we increment this one to 3, right? Because this class is also done. After we are done with the course 2, we break this rule, this connection to 3 because the 3, this edge means the 3 has some prerequisite. After we are done with 2, then we see that we decrement this one to 0, right? Because it does not have any in degree. Then we add this 3 to the queue here, right? And we increment this one to 4. Then after we take this from the queue, because we take that class, then that course, then we say, okay, we are done with this course too. After we are done with this course, then we break this connection, this edge. Then it was 1, so we just, now its the edges, in degree is 0 because we are done with all of this prerequisite, right? Then we add 4 and we take this 4, then we increment this one 5. So how many classes we had at the beginning? At the beginning we had total number of classes, it was 5, and we are done with all of them. So we see if number of courses at the beginning, if it's 5, and if it's equal to the number of courses taken so far, it means that we are done. We can finish all of the courses in the list. So let's go back to the example number 4. You can see here, okay, in degree is 0. So the course 0 doesn't have any dependency. Sure, we can take it. No problem, right? Then when we go to the course 1, after we are done with the course 0, we can break this rule. Then we decrement this one. It was 2, now it's 1, right? So we can take the courses only if it does not have any prerequisite. You can see that its prerequisite, it has 1. This is 1, this is 1, this is 1. All the courses, they have dependency. They all have something incoming. They depend on other courses as a prerequisite. So we cannot take those courses. So which means like total number of courses here, what? We finish only 1 course, right? So we finish only number of courses taken is 1. But what's the total number of courses? 5. Are they equal? They're not equal. So which means that we cannot finish. we cannot finish this taking all of the classes. So at the end we need to return false. So this is the idea, right? We need to make sure that there is no prerequisite. And how we can say prerequisite? It doesn't have prerequisite because we can just say it does not have, it has in degree of 0. Is a number of edges incoming to that specific class or the node is 0, basically, right? So now let's look at the code. Okay, so this is the code. So let's see. If initially we initialize this graph as a dictionary, and all the in degrees we fill them with 0 times number of courses. Like we fill them if we have 5 courses, so we fill them with 5 zeros, right? Now we have to count the number of in degrees, right? We need to build the adjacency list. That's how we build adjacency list. So we loop this prerequisite, course, and prerequisite because it has 2 elements, right? The first course and it has a prerequisite. So here we add the graph prerequisite and we append the course. And at the same time, we for the course, we increment the in degree. And here to the queue, we need to initialize the queue with the courses that have no prerequisite, which means like in degree, if the in degree is 0, so it does not have any prerequisite, right? Here in degree, whatever the course, whichever course has in degree of 0, then we can add that to the queue. And we initialize here number of courses taken as 0. Then and now we're gonna start processing the courses that are in the queue and which has in degree of 0, which means that it does not have any prerequisite, right? If the queue is non-empty, then we pop the course from the queue, and we increment the number of courses taken by 1, and we check all of the neighbors of the course that we are taking, and we decrement there in degree, because once we are done with this course, which means that we are done with one of the prerequisite, and we need to decrement all the neighbors of this course in degree, right, by 1. So if the in degree of the neighbor of the course that we are taking is 0, then we need to append that course to the queue to process or to take after we are done with this course, right? Then this loop will continue to finish all the courses. And at the very end, if all the number of courses are equal, taking courses, right, during the process, if it's equal to the number of courses at the very beginning, for example, in this case, we have a number of courses, let's say 5, right? Number of courses is 5, and we can see we could finish only 1 course, right? And which means that they are not equal. Well, if they are not equal, then it means that we cannot finish all the courses. And while in this case, number of courses here is 5, right? And number of courses that we could take is number of 5 too. So if it's equal, then it means like, where we can take and we can finish all of the courses, right? So this is idea. So initially we built this in degrees prerequisites in the graph or the adjacency list. After that, we add all the classes with in degree 0, which doesn't have any prerequisite to the queue. We start processing that queue whenever that neighbor has. Whenever we are done with that course, we decrement all of the in degrees of the neighboring courses, right? Then if it's 0, we add it to the queue. We just start processing that node, right? If they are equal, so then we can finish all the courses. Then this returns, if it's equal, this returns true, otherwise it returns false. So this will do the solution. So a couple of steps. So adjacency list, and collect all of the courses with in degree 0, then start processing that, start taking those courses, right? Once we are done taking those courses, start like taking the next course, which does not have any dependency, right? So please subscribe to the channel and ask your question, and comment this if you would like to see more classes or more problems, right? Thank you very much, and see you in the next videos.